Hello and welcome to a new lesson on Docker terminology and architecture. Let's dive into the fascinating world of Docker, starting with the very basics, Docker images and containers. Imagine Docker images as blueprints. These blueprints are immutable, meaning they don't change. They contain everything your application needs to run: code, libraries, tools, and dependencies. Now, when we use these blueprints to create a running instance, what we get is a Docker container. Containers are isolated environments, but they are not entirely separate. They share the host operating system's kernel, making them lightweight and efficient. Moving on, let's talk about the Docker file. Think of the Docker file as a recipe. It's a simple text document containing all the commands needed to build a Docker image. With the Docker file, Docker can automate the process of image creation, following the instructions line by line, just like following a recipe to bake a cake. Next, we explore Docker Hub and Docker registries. Docker Hub is like the world's biggest library for Docker images. Here, you can share your images with the community or find images others have shared. A Docker registry, on the other hand, is where these images are stored. You can use public registries like Docker Hub or set up a private registry for your organization's use. At the heart of Docker is the Docker engine. This is where the magic happens. The Docker engine uses a client-server architecture consisting of the Docker daemon, a REST API, and a command line interface. The Docker daemon is the workhorse, managing Docker objects such as images, containers, networks, and volumes. You, the user, interact with Docker through the CLI or sometimes indirectly through other tools like Docker Compose. Finally, we touch on two important concepts: volumes and networks. Volumes are used for data persistence. They ensure that data generated by or used by Docker containers isn't lost when containers are stopped or deleted. Docker's networking capabilities allow containers to communicate with each other and with the internet. There are different types of networks in Docker, each serving different needs, from simple bridge networks to complex overlay networks for distributed applications. And that wraps up our overview of Docker's key components and architecture. With these concepts in hand, we are ready to dive deeper into Docker's capabilities and start working with containers ourselves. Stay tuned for our next lesson, where we will explore Docker commands and container management. Thank you for joining, and see you in the next lesson.